mechatronics. Right? So these on the outer rim of this circle, they are the applications. For example, automotive, aerospace, medical. So this is the defense system, consumer products is related to us, manufacturing, and then this is materials processing. So the term mechatronics was coined by the Japanese Ministry of International Trade and Industry, and around 1980s. 1987, I'm sorry. So yeah, it's either 1970 or 1980s. It refers to the synergistic integration of precision mechanical structure and motion, electronic control, and system controls in the design of industrial products and processes. This is original definition, okay? But as the technology evolves, people have been adding more and more components in this concept, mechatronics. Let's see, control, electronic, computer, mechanical. We have so mechanical CAD, electronic mechanics. So this is a digital control system and control electronics. So mechatronics is the methodology. So it is the methodology for designing products that exhibit fast, precise performance achieved by considering not only the mechanical design but also the use of servo controls, sensors, and actuators. What is a servo? We are going to talk about this one in detail, okay? When we talk about actuators. Mechatronics can bridge the existing gaps between mechanical and electrical engineering and electronic information technology. So here is a basic, this is components of our typical mechatronic system. So this is a mechatronic system, and we have actuators, we have sensors. So this is sensors here, sensors and actuators. So when the sensors get some info from our environment, and then this is information and will be fed into this is the industrial signal conditioning and interfacing. Okay, so remember this one is for the preparation of the signals that the microcontroller is going to process. So this is not a microcontroller yet. See, you can see for conditioning and interfacing, because some raw data, raw signals, and the system cannot process, and you need to do something. Okay. So this is the conditioning and interfacing. For example, discrete circuits, filter, amplifier, AD, and DA. AD means analog to digital converter, and DD means that digital to digital. And this is actually, you can either decrease the magnitude of signal or enhance the magnitude of signal. It depends on your microcontroller. Okay, you have a sense, everyone? And DD means digital to digital. You do not change the data's nature, but the magnitude is altered, just to adapt to your microcontroller. So microcontroller, so digital control architectures. So there are logic circuits, microcontroller, SBC, PLC, and SBC is single board circuit, a single board controller. Right? PLC is programmable logic controller. Microcontroller is more general one. The single board controller, it is a very, very early version of this microcontroller. That's about 1970s. One was a P. Right? But I want to tell you the history. And we are going to focus on microcontroller and PLC. Actually, PLC is a specialized microcontroller. So sequencing and timing, logic, arithmetic, control, and algorithms, and communication. And you can see within this box, it is actually the functionalities of our brain. Well, that's great. Okay. So after this microcontroller process something, then you can just send out the signal. Right? Send out the signal. So also conditioning and interfacing, because it depends on what kind of actuators you are using. So you need to either to have digital to analog, the converter, or digital to digital enhancing amplifier PWM. PWM is pulse width modulation, and power transition, power or amps, and then you can just displace it, or you can just drive the actuators. Okay, so this is a basic architecture of a typical mechatronic system. And here, this is the mechatronic systems. So we can see we are very familiar with these tools. And in our house, we have this one. Computer, we use computer every day, cars, and transformer. So this one is very advanced high-speed trains, maps, this is consumer electronics. So this micro to micro, this is applications. So this is manufacturing application. This is, you can see, because I'm a manufacturing guy. Okay, so this is a micro factory. So this is a sewing. This is desktop size factory. So this one is a sewing machine. Building small parts with a small factory, greatly reduce space, energy, and materials. Very small. So you can see here is a drilling unit. How to drill it. So here is a manufacturing application. CNC. This is CNC. We have a CNC in the audio hall. CNC bending. So here is a microcontroller. Here's a microcontroller. Here's a this is a screen, and you can control it. Everything is automated. You can just put a raw material there and then press some key. But before you press the key, you need to program it. And then after you press the key, a final product will be generated. So this is a CNC machine. Machine definitely it is a mechatronic system. So here is a CNC control. So this can reduce the cost. So here is the high-speed trains. So this is for Japan, this is for German, and in China also. And Chinese people, they have developed their high-speed the trains also. It's very fast, very stable, and very comfortable. So here defense applications. Here is unmanned aerial vehicle. So nobody is here, okay? So you just use the remote control to control it. So here's a stealth bomber. This is a highly sophisticated one. So this is the electronic system. Then this is a sanitation application. So in the restroom we have these kind of things just to reduce the contact between our hands and between our hands. So you use this is non-contact sanitation application. So we have a proximity sensor. As long as you put hands there,